Okay. So we started with a relabeled graph of your basic quadratic function. So what's the obvious thing that's been done and everybody pretty much saw? Well, it's been moved to the right about 2 units because the vertex is now over here where it should be over here for the basic function, right? And then somebody said, well, it's stretched. Okay? It looks like it because we're used to seeing it more steeply, but if we graph the basic quadratic function, like it's got the point 2, 4, well 4 is only up here, right? Got the point negative 2, 4, but 4 is only this high. It looks like it hasn't been stretched, okay? So this looks then like the basic quadratic function basic y equals x squared function. Relabeled by adding what to all the x values? We add 2 to all the x values, right? So that's the same as shifting plus 4 units plus 2 units in the x direction. Okay? What's the equation for the function? So is the new function y equals x plus 2 squared or y equals x minus 2 squared? How can you test it? Well, you can plug a value of x into this function and see if it fits this graph, or a couple of values of x. You choose a couple values of x, plug into this function and see if it fits this. So what value of x do you want to use? Now I don't recommend 0, because if you plug in 0, you're going to get 4 either way, right? Now that's going to fit this function because it is 4 when x equals 0. But that's not a good choice because it won't distinguish between these two. Okay? So what do you want to use? 2. Okay? So, and what should you get when you plug in 2 for this curve here? What are you going to get? What do you want to get? What had you better get if you got the right function? 0, because y is 0 when x equals 2, right? Okay? And hopefully we've done enough work with reading graphs that that's very clear. Okay? Well, if we plug 2 in here, what do we get? Sorry? We get 4 squared, right? Which is 16. Okay? So, is 216, does point 216 fit this graph? No, doesn't fit. Okay, plug 2 in here. What do you get? Does the point 20 fit this graph? Darn right it does. Okay? So if you're ever not sure which way it goes, you can always test it. It's either going to be plus 2 or minus 2, right? Okay? So if you forget, you can test it. There's a rule also, but there's common sense. You don't need a rule if you have the common sense, but it's good to have the rule so you can compare it to common sense. In case your common sense is screwed up, if you got the rule right, you can resolve it. Okay, well, here we go. Okay, so Okay, and we could have chosen x equals 1. 1 minus 2 squared is 1. Okay, does 1 seem to fit? Well, there's 1 seems to fit, right? Okay, we got that? That's how we connect this to the relabeling. Relabeling is pretty easy to understand. The rules for transformation screw everybody up. They're not easy to understand. Okay? So that's why we chose this, to do this with relabeling. But there's the connection. Now, generalization. That's going to be worth looking EI of a road, or we'll live with it. Generally, if you replace x by x minus h, the graph shifts 8 units in the x direction. Okay? And if x is replaced by h, and the function y equals f of x, the function is y equals f of x minus h. Now, when you come in next time, you will have mastered function notation well enough to understand how to use this idea. Okay? Okay, so there we have this. Now, what if the graph looked like this? And actually, let's go ahead and fix it a little bit. Okay? I'll also label, okay. This graph here is this. What are we going to do with this graph? What's different and what's the same?